Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, state where possible vector parametric and symmetric equations for each of the following lines. So let's start with the first line. For the first line, we are given that the line passing through point B and parallel to line passing through points M and N. So we should start by finding the vector equation of the line. The general equation of a line in vector form is in this equation, vector r represents position vector of an unknown point that lies on the line. Vector r0 represents position vector of a known point that lies on the line. T is the parameter and it can be any real number, and vector m is the direction vector of the line. As per the problem, the point B lies on the line, so we can use point B for position vector r0. We are also given that the line is parallel to the line that passes through points M and N. Parallel lines have the same direction vectors, so we can find the direction vector of the line passing through points M and N, and that will be the direction vector of our line. To find the direction vector, we should subtract the position vectors for the given points. I'm doing ON minus OM. We can also do OM minus ON. For position vector ON, we should use the given point N. And for position vector OM, we should use the point M. Now we can subtract the vectors by subtracting their x, y, and z components. So for x component, we have to do -2 minus -2, which is equal to 0. For y component, we have to do 4 minus -2, which is 6. And for z component, we have to do 7 minus 1, which is equal to 6. This is the direction vector of the line passing through points M and N. We can reduce this direction vector by dividing each component by 6. We get 0, 1, 1. We can use either of these two direction vectors because direction vectors can be scalar multiples of each other. So the direction vector for our line is 0, 1, 1. Now we can write the equation in vector form. Now we can use this vector equation to find the parametric equation for this line. We have to use an unknown point x, y, z that lies on this line for position vector r. Now we have to break up this vector equation into the parametric equations. So let's start with the x equation. We have to use the x components in these three vectors. And we'll multiply the components of the direction vector 0, 1, 1 by t. T times 0 is 0, so we can ignore the 0 term. So the x equation is x equals -2. Now we can write the y equation using the y components. 1 times t is t. And next we can write the z equation using the z components. We can ignore the 0 term in the z equation and rewrite the three equations. These are the parametric equations for the first line. Now we can write the symmetric equation, and for that we'll have to isolate t from the x, y and z equations. Now in the x equation there is no t term, so we can write the x equation as it is. Now we can isolate t from the y equation. We can isolate t by subtracting 3 from both sides. So this is the expression for t from the y equation. In the z equation, t is already isolated. Now we can equate the expressions for t from x, y and z equations to write the symmetric equation. Now since the x equation has no t term, we won't be able to write the x part of the equation in symmetric form. So we'll start with the y part. The denominator will be 1. For the z part, the denominator will be 1. And for x part, we'll just write x equals -2. So this is the symmetric equation for the first line. Now we can analyze the second line. For the second line, we are given that the line passing through point D and E. So let's start with the vector equation. For the position vector r0, we can use either of the 2 points. I will use point D. Now we can find the direction vector of the line. We should subtract the position vectors of the 2 given points. I'm doing position vector OE minus position vector OD, but we can also do OD minus OE. For position vector OE, I'll use point E. And for position vector OD, I'll use point D. Now we can subtract the vectors by subtracting their x, y and z components. -1 minus -1 is equal to 0. 1 minus 0 is 1. 0 minus 0 is 0. So this is the direction vector of the line. Now we can write the vector equation. Now we can use this vector equation to write the parametric equations. So for that, we'll use an unknown point x, y, z that lies on this line for the position vector r. Now we can break up this vector equation into x, y, and z parametric equations. For the x equation, we'll use the x components of these vectors. And we'll multiply the components of the direction vector by t. 0 times t is equal to 0, so we can ignore the 0 term. So the x equation is x equals -1. Now we can write the y equation using the y components. We can ignore the 0 in this y equation. So I get y equals t. Now we can write the z equation. I get z equals 0. Now we can write these three equations together. So these are the parametric equations for this line. Now we can write the symmetric equation. Now in the direction vector, two components are equal to 0, x and z. That means we cannot write the equation of this line in symmetric form. So there's a very important concept we need to understand and memorize. So we can explain our answer. So this can be the final answer for the symmetric form of equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.